Chapter 4, Section 11 is what we're going to hit on today. More stuff with logarithms today. So, let's just kind of get going here. So properties of logs today, Section 11-4. We're going to use the product rule for logarithms. We're going to use the quotient rule for logarithms, the power rule for logarithms, and then use them in alternate forms. We're really doing all four objectives today. Problems will get kind of more complex kind of as we go along. Start out with property rule, the product rule for logarithms. Essentially, what we're going to be doing today is we're going to be able expanding logarithms or condensing them. So either writing them as an expanded form or really as a single log with these different rules. So the first rule says that if you have two logs that are multiplied together, so log base b of xy, so log base b x times y, that's equivalent to saying log base b of x plus log base b of y. So something great for your notes, log base b of xy, that's equal to log base b of x plus log base b of y. So those things are equivalent to each other. So for example, let's say that we had log base 4 of 4x. That is equivalent to log base 4 of 4 plus log base 4 of x. Those are similar statements to each other. The converse of that is also true. So, I wish this would let me erase it. It doesn't, so I just got to sit here and delete it. But the converse of this is kind of also true. So, and this is oftentimes what we see more often, is if I see something of log base 4 of 3 plus log base 4 of 6, we've kind of got that expanded, this is called expanded form. More often than not, what we want to be able to do is we want to be able to solve them. So we want to be able to take it from expanded form down to single log, and this kind of just use this in reverse. If you're adding two logs with the same base, and the bases have to be the same, this is the same thing as log base 4 of 3 times 6, which is obviously just log base 4 of 18. We actually do this method a little bit more often than going the other direction. But you got to be able to kind of move them in both directions. Either take it from a single log out to an expansion, so adding, in this case, the product rule, product means to multiply, or taking it from a expanded form down to a single log, that type of form. So again, so if you use the product rule to rewrite this example, this is just going to become the log base 4 of 3 plus the log base 4 of 7. And you're done. You're not trying to find a solution to anything like that. You're just rewriting the logarithm. And that is taking this and rewriting that logarithm. Okay? Going the other direction then, if we have log base 8 of 10 plus log base 8 of 3, this is then equivalent to log base 8 of 10 times 3, which is log base 8 of 30. Okay, taking it from expanded form to a single log. Okay. 8 times k, and I'm just going to throw this one up here. So log base 8 of 8 plus log base 8 of k. Pretty straightforward. And then, we talked about this yesterday a little bit. That's why that's a 1 there. Remember when you take log base 8 of 8, that's just 1. We talked about that a little bit yesterday, but it would have been okay if it would have left it. This one, log base 5 of m squared. When you do this one, if you think about m squared, it means m times m. So one of the ways you could do this is we could go log base 5 of m plus log base 5 of m. But since those are the same thing, this then becomes 2 log base 5 of m. So it takes it and condenses it down. Now, you can skip the process by using a rule. And essentially the rule says that to change this, all you have to do is take the 2 take the exponent and put it out front of the log base of whatever that is. They're equivalent to each other. Okay, that's the reason. This is the reason why it works. This is the reason. Then that's what you can do. Is take that exponent, put it out in front of the log, leave the base the same, and whatever was there is what's there. And that's kind of, again, kind of taking something and expanding it, and I'm assuming that's what they'll do. Okay. Again, assuming m is greater than 0. Okay, so that's the product rule. The quotient rule, well, product is if you add, quotient probably then if you subtract. Okay, so the quotient rule, a little bit hard to see in there. The quotient rule says log base b of x divided by y is equivalent to log base b of x minus log base b of y. Okay, number-wise, if we have log base 4 of 3/4, that's equivalent to log base 4 of 3 minus log base 4 of 4, which would just be 1, but you understand where that's going. Okay? And again, you want to be able to go both directions with this. And again, we go the opposite direction more than we go in this direction. Well, maybe not more than, but we have to be able to do it. So if we have something like log base 5 of 5 minus log base 5 of 2, since it's subtraction, this is going to be the same thing as log base 5 of 5 halves. And that's your solution, taking it from expanded form to a single log. So let's look at a few more examples. So log base 7 of 9/4. 9 divided by 4, so that's going to be log base 7 of 9, the numerator, minus log base 7 of 4. You're done. Nothing left to do with that one. Okay. Going the other direction, log base 3 of p minus log base p of q. So this would just become log base 3 of p divided by q. And then they'll probably say q cannot equal 0 because you can't divide by 0. Just my guess is what they're going to put in there. But again, taking it and expanding it down just a little bit. Both p and q are greater than 0. Okay. So log base 4, again, you could go ahead and do this one. We'll just kind of show the answer. So log base 4 of 3 minus log base 4 of 16. They just solved it, but you don't have to do that. That's fine. Okay. The power rule. We talked about the power rule of logarithms already. I kind of mentioned this before when we were doing the product rule. This says the log base b of x to the r, and I talked about this earlier, is equivalent to r times the log base b of x. Okay, you take that exponent, move it out front, and this is the power rule of logarithms. You take that exponent, put it out front, and then just put log base b of x. So if we had log base 6 of x to the third, this would be equivalent to 3 times the log base 6 of x. And you're done. But again, you got to be able to go the other way. So if I had 4 log base 3 of 2, I could rewrite this as log base 3 of 2 to the 4th power. They're equivalent to each other. Again, that's the power rule. And being able to go both directions kind of with that power rule. Okay, so some assumptions. So we've got log base 3 of 5 squared. 2 goes out front. Log base 3 of 5. You're done. Hey, you've taken it and rewritten it. Which is what we did. Again, log base a of x to the 4th. 4 log base a of x. And you're done. It's not going to change. They're going to say that a is like to the 1/2 power, and they go to 1/2 out front, but we wouldn't do anything like that anyway. And we wouldn't do anything like that either. So, some special properties that you need to know, just like yesterday where we said log base b of b was equal to 1, or log base b of 1 was equal to 0. If you take the b, your b value, log base, if you take b to the log b of x, that's just equal to x. So if we had 10 log base 10 of 4, your answer to that is just going to be 4. also goes to the fact that log base b of b to the x power, that's just equal to x. It's just kind of one of those special properties. So if I have log base 6 of 6 to the third, our answer is just going to be 3. And if you think about it, you can see why. Because this would be 3 log base 6 to 6, and we said that that was 1. So 1 times 3 is 3. So it works. Okay, so those are just some special properties. So now let's put them all together. These are special properties. We did some of those examples. We're okay with those. These are our rules. So we've got the product rule, the quotient rule, the power rule, and then those special properties. So kind of keep those in mind now as we take these and take them kind of to the next level, where it's not just one thing going on. So we're going to use the properties of logarithms to rewrite each expression. Assume. Okay, so we've got this single log. Log base 6 of 36 equals m to the fifth. So we have to figure out all we got going on here. So we've got 36 being times by m to the fifth. So we've got multiplication in there. So since we've got multiplication in there, that means I can rewrite it as an addition problem. So I could rewrite this as log base 6 of 36 plus log base 6 of m to the fifth. One step. I don't think we're done though. So we've got to look now at each one and see if it can be simplified any further. If we look at that, it's done. I mean, could you go log base 6 of 6 plus log base 6 of 6 plus, yes, you could just leave it. It's done. The second one, if we look at that, that's not done because we've got that m to the fifth power, so we can simplify that a little bit more. So this is going to remain log base 6 of 36 plus, now that 5 is going to come out front because of the product rule. And this would be a good answer. They might tell you that that's 2, but that's okay. Log base 6 of 36 plus 5 log base 6 of m. That's the right answer. And you're not going to get it wrong if that's what you put. Okay. So what we did, they put a 2 there, but that's okay. I said that's what they were going to do. We haven't talked about how they got that yet. We'll talk about that eventually. Okay. All right, so like I said, we're not going to really do any that have... It's a weird question. We're not going to have really any that have square roots in them. We'll see how they did it, but again, they wrote it as a half. Okay, let's look at this one. A little bit longer, but that's okay. So we've got division going on. So I'm going to take care of division first. So we got log base q of 8r squared divided by m minus 1. Lots going on in this question. This is going to be an actually quite long answer. All right, so I'm going to take care of the main division first. So I'm going to go log base q of 8r squared minus log base q of m minus 1. I'm going to put that m minus 1 inside parentheses. Now, if we look at this first one, I've got multiplication going on. So I can go log base q of 8 plus, but I notice the r is squared, so I'm just going to do it in one step. So this would be 2 times log base q of r, and then we've got minus log base q of m minus 1. And I'm probably going to stop right there. I mean, you've got m minus, just leave it at this point. We'll see what they do. I would say at this point, stop and put that as your answer. We'll see what the book does. See, because there's one more thing that they could do, but I don't know why they would do it. Let's just see what they do. We did all of this, and that's what we got for our power rule. Oh, so that, yeah, we had the answer. So now we're going to go the other direction with it. Now we've got it in this expanded form, and we want to write it as a single statement. So to write it as a single statement, we're adding, so that means we're going to multiply. But notice I've got this. So really, I could rewrite that first as log base a of x squared. Plus, I could rewrite this as log base a of y to the third. Now they're being added, so I could go log base a of x squared y cubed. Ta-da, and they're done. Okay. Yeah, lots to it, and maybe you could have just done it in one step. But yeah, it works out, and it really kind of works out nice. And that's our solution. Okay. Now again, you got to check the form out. It's log base 4 of 3x plus y, so you kind of see what we're going on, and there's no property for that. Okay. It looks like you're adding two things together, but you're not. There's no property to find the log sum. That's why they didn't do the subtraction one. The last thing I want to talk about is when you get something like log base 10 of 5, it'll tell you in the directions not to use your calculator. Use your calculator. In your calculator, you've got that log button. It just says log. It's understood that there's a 10 underneath there on the calculator, and only a 10. So if you had something like log base 2 of 5, right now you can't solve that. But if you just have like log of 5, that's the same thing as log base 10 of 5. You can punch that in your calculator by hitting the log key and then just hitting 5, and you would get an answer of 0.6990. In your assignment today, there's a couple questions that say, show this without using your calculator. Use your calculator. I'm not going to do it without using my calculator. I wouldn't expect you to do it without using your calculator. So just do those using your calculator and understand that it has a base of 10. So there is 11.4. So we've got the first 4 sections of chapter 11 done. We've got a quiz coming up. So you'll have a quiz on Thursday or Friday of this week, and then we'll also move on to the next section as well. So have a good one.